Hey guys, welcome. We'll get started here in just a couple minutes. I'm gonna give a few minutes for everybody to join here. All right, let's get started. Actually, let me use this just so I'm not covering up the screen. There we go. Welcome everybody. Thanks for joining. I'm actually really excited about this webinar. We're going to be announcing our next open source project that we're going to be giving to the community. And so I'm excited to talk about it here. My name is Chris. I'm going to be hosting this. I'm one of the co-founders of Massdriver, which we'll see near the end of the of this webinar. It's a visual platform for deploying, managing, and observing cloud resources and applications. We have other members of the Massdriver team in the chat and Q&A, so they can answer any questions that you have. So feel free to ask questions in chat, and we will try to get them answered, perhaps even on stream, if it's relevant to what we're talking about. The webinar is also going to be recorded, and it'll be uploaded to the Massdriver YouTube channel. So if you want to follow up afterwards and follow along with the webinar, you can find it on YouTube. So today we're going to be talking about a tool called Airflow, and we're going to be, or sorry, it's Airlock, not Airflow, it's Airlock. We're going to be exploring the different use cases for it. If you'd like to follow along with me, I'm going to paste some links into the chat. First one here is the link to the Airlock, to the the actual webinar resources that we're going to be using. So I'm going to be spending most of my time actually in a terminal or in VS Code, and all of the materials are right there available to us. So the other link here is going to be a link to Airlock, which is the actual project itself. You can go check that out. We're also going to be using the Massdriver CLI near the end, and there's a link to the Massdriver CLI right there. And the last piece that I'm going to share is a lot of Airlock is around JSON schema, is going back and forth between JSON schema and different IAC tools. And so I'm going to share a link to JSON schema's official website. We'll also dig into that, this isn't a JSON schema webinar, but it is very relevant to what we're talking about. So go ahead and get that stuff downloaded if you'd like to follow along. But like I said, if you don't have the time, you can just find this on YouTube afterwards and follow along then. So let's go ahead and get started. So what is Airlock? Airlock is Massdriver's newest open source project. And the main purpose of it is to allow translating back and forth between a lot of IAC languages, such as Terraform and OpenTofu have HCL, Helm uses YAML for its values, and there's some other ones that use JSON like CloudFormation. And so what Airlock allows you to do is actually translate back and forth between, for example, in Terraform, HCL to JSON schema and JSON schema to HCL. Airlock itself is both a CLI as well as written in Golang, and so it can be used as a library. And we actually do that in the Massdriver CLI. The Massdriver CLI uses the Airlock libraries to be able to do some of the stuff. What are some of the benefits of using it? So many of the IAC tools are limited or provide no validation on inputs. JSON schema is actually a powerful validator for JSON, and most IAC tools are able to understand and interpret JSON. And so by using Airlock, you can generate JSON schema documents that can help ensure that your IAC inputs don't have invalid values, and not just invalid. There could be policies you have. For example, maybe you don't want something to be able to be deployed into public subnets or something like that. You can use JSON schema to ensure that the inputs are restricted to just certain values. So that's some of the value, and we'll see how all of that works in the demonstrations coming up. So what is JSON schema? JSON schema is a specification that allows you to define the expected structure of a JSON object and then validate any arbitrary JSON object or structure against it and see whether the JSON matches the schema or not. So there's actually an example we have right here on this slide. Excuse me, on this slide. The left side of this slide is JSON schema, and the right side is an actual JSON blob. And so if we just walk through the schema, we can kind of see how we're defining the expected structure of this blob. And so the first thing we'll see is the type is an object, and in JSON that's just going to be something with a bracket. And you'll see that very top level is a JSON object. Then that object has a set of properties, and the first property we define is a name field, which is type string. And you'll see over here we have a name field that is a string. We have an age field, which is an integer, and over here we have age as an integer. We have married, which is a Boolean, and over here we have married as a Boolean. And then we have education, which is an object, and you'll see it is an object over here. It is wrapped inside these curly braces. And within that object, we have another property named college, which is a string, and you'll see that that shows up over here as well. Now, this allows us to define the expected structure. Now, I want to be clear, the order here doesn't matter. JSON is inherently unordered, and so it's just a coincidence that I wrote out these properties and they're the same order on the left and the right. So order doesn't matter at all, but what is missing from this is the actual validation of the fields. And the only reason it's not in here is simply there wasn't really a lot of space to be able to add a lot more stuff, but we're going to be seeing a lot more of actual input validation. So for example, the string, we could put a length limiter on the string, a min length or a max length on the string. We could also use a regex pattern to check it against a regex to make sure that it passes. The integer could have a min value or a max value. You can do multiples of a value. Conditional fields, you can, for example, that true, we could make that conditional. We could define in the schema that if married is true, we're going to require another field, which would be the spouse's name or something like that. And so this is just a very simple example where you see we've defined the structure of JSON, and now we have a JSON blob which fulfills it. And so we won't really talk much more about JSON schema itself. If you are interested, you can check out the link that I sent earlier. I believe it's json-schema.org. And there's plenty of resources around that. I just want us to have a base understanding of JSON schema before we actually get into using Airlock. So now that we've talked about that, let's actually jump into Airlock and see how it works. So I'm going to open up a terminal that has the webinar materials. So in the Massdriver GitHub repo or org, you can find webinar Airlock, and that's what we're going to be going through here today. So you'll notice we just have two directories in here. We have a Helm directory and a Terraform directory. We're going to use these two as examples for how Airlock can help us validate inputs for both Terraform and for Helm. And we're actually going to start with Terraform. So if we open up the Terraform directory, you'll see we have three files here. We have a main.tf, and you'll see this is really just a trivial example. Both of these are just trivial Terraform module and a trivial Helm chart. But you'll see we have just two resources, a random pet, a random password. The main thing we care about is the variables, because this is what Airlock is going to help us with. So you'll see that we've actually defined 5 variables here. We have the length of the pet name. We have the password length, and then whether or not to have lower, upper, and special characters within it. All right. And then we also have a variable.auto.tfrs.json file here that the intention is that this now declares, or I should say defined all those variables that we declared earlier. So I'll also point out that, like I mentioned earlier, even though Terraform is primarily in HCL, it actually understands JSON. A lot of what you do in Terraform can actually be done in JSON. You can define variables in JSON, and you can also define the variables and the values that they have. So let's jump into actually using Airlock. So I'm going to open up a terminal here. And I'm in that in this webinar directory. Let's cd into Terraform. And the first thing I'm going to do is actually run the Terraform so that we can see that this is valid Terraform. It does run. Everything is good right now. So if I do Terraform apply, you'll see it's going to create the two resources, the password and the pet. And we'll say, yes, go ahead and create that. So the Terraform is good. Let me go ahead and destroy it. Terraform destroy. There we go. Yep. Okay, so our Terraform is good. What we want to do now is, let's say we want to use JSON schema to actually validate the inputs that are going into this Terraform module. And so we're going to be using the Airlock CLI for this. So this is already downloaded. I already have it on my system. If you need Airlock, you can download it from the releases page on the repository. And you'll see right now we have specifically two IAC tools that we have commands for. One is Helm and one is Terraform. And so we're going to be, for this first one, we're going to be using the Terraform one. If we look at Airlock Terraform, we have input and output as subcommands. And input is going to be, we're taking in a Terraform module and we're going to be spitting out a schema file that represents the variables. The Terraform output is going to go the other way. We're going to be taking a schema and we're going to be outputting variables, HCL variables, or Terraform variables, I should say. So let's run Airlock Terraform inputs. And then we see the path through the module. And the reason why we're doing a path here and not a file is, if you've worked with Terraform, you may know variables can actually be declared anywhere. Oftentimes, they're all declared in a single file, usually called variables.tf. But technically, you can define variables anywhere in main.tf and provider.tf. In any of the files in the module, you can declare them. So that's why we just take in a directory, and we'll scan the directory and look for any variable declarations across the whole directory. So the directory is actually the current one that we're in, because we're sitting in Terraform. So let's run it. And you'll see what comes out is JSON schema. It looks very similar to the example that we had in the previous slide, where we have an object with a set of properties, pet length, password length, whether or not to have lower, upper, and special characters for passwords. We also have this required field, which we didn't get into previously, but this says which of these fields must be in this object. And here, all of them must be in the object. And the reason that's the case is if you didn't notice, if we go back to the code, none of these have any default values defined for them, right? If we declared a default value, in fact, let me do that real quick. If I do default equals true for password lower, and I save that, and if we go back and we rerun that, you should see that password, which one was it? The default here is now true, which is exactly what we wanted. So let's now actually output this to a file, because what we want to do is use this schema to start validating the actual variable inputs. So let's run that, and let's output this to, let's just call it variables.schema.json, just like this. And now if we cat that file, we have this in a separate JSON file. Now, what we can do is we can actually use Airlock to do JSON schema validation. So that's something we haven't really talked about, is how do you validate? There's actually a lot of online tools that you can use. So if you just search for JSON schema validation, there's numerous tools where you can add a schema file and you can add a JSON document, a blob, and it will validate whether or not the blob matches the schema or not. We actually also have, if you look at Airlock, we have a validate subcommand, which allows us to specify, if I go Airlock validate, there's a -d document and a -s schema. So we can use Airlock to actually perform the validation. And so if we do Airlock validate, and the document is going to be the actual JSON blob. So in this case, it's going to be the variables.auto.tfrs.json. And the schema is going to be the variables.schema.json. Just like that. And the document is valid. This is great. Now, really, we haven't specified anything besides that the objects that must be there, or I should say the properties that must be there. So let's actually start adding some validation to this so that we can see how the JSON schema validation works. So let's just say, for example, that your company has a password policy that says that the passwords must be at least 12 characters in length. So if we look at the schema document right here, for password length, let's just add a minimum here of 12. This is now specifying the minimum value that this can be. And you'll see that we should technically be in violation of this because our password length is being set to 8. So let's go ahead and run and see if this now fails. I don't think I saved. Let me save it real quick. I didn't save. There we go. Let me save the schema, and now let me rerun. And there we go. It is erroring out. It says password length must be greater than or equal to 12. And so this is a way that we can start now specifying exactly what the constraints are on the input variables that we're giving to this module. We could also say, for example, you could potentially be using somebody else's module. You know, there's technically a lot of modules in the Terraform repository, and you may use one of those modules to create some infrastructure, and you don't get to define what are variables and what aren't variables. And so you may be stuck with certain fields being variabilized that you don't really want to be exposed as variables. And so what you can do actually in the schema, I mean, technically you can modify the Terraform if you wanted to, but if you were just using it, you could say in the schema, you know what, even though this thing is a variable, for example, let's go password special, we're going to say it's actually going to be just a const value of true. We require special characters in our passwords as well. And so even though this is, excuse me, variabilized, we want to enforce that it must always be true. And this should also be in violation, because you'll see password special is actually false. And so I've saved it this time. Let's go back and let's run the validation. And you'll see now both of these are caught by the schema validation. Password special must be true, and the password length must be 12. So let's go back in. Let's update that in the variables. Let's update password length to 12. Let's set the special to true. Let's save. And if we rerun validation, the document is now valid. So this kind of shows you how you can use JSON schema to validate the inputs and make sure that you can encode the requirements and the constraints that fit your organization into the actual code that the Terraform modules that you give to your engineers. So one thing that I want to mention here is that Terraform actually, I think it was in version 0.13, they actually added a validation block to variable declaration. So when you declare a variable, you can actually add in here. We'll see if you can, see there's a validation block where you can specify some constraints around how this should look. What I will say is it is useful. However, there's far more rich validation that's offered by JSON schema than what you get through the built-in validation. Unfortunately, Terraform doesn't have native support for JSON schema validation. So you would likely need to add this validation step as part of your CI/CD or deployment pipeline. But I do recommend JSON schema over the standard validation. Being able to test against different values or have things conditionally required or things like that, you're going to have a much easier time enforcing things like that with JSON schema than you will trying to do it with a built-in native Terraform input variable validation. So that shows you Terraform. We're going to get some other examples in the Helm one. So let's jump over to Helm. And Helm's actually kind of exciting because Helm does have native support for JSON schema. So we can see how we can just natively use JSON schema to do input validation. So I'm going to minimize Terraform, and I'll open up the Helm repo. And you'll again see this is just a trivial example. We're not actually going to be deploying this Helm chart into a Kubernetes cluster. We're just going to be using the Helm template command because that renders the manifest for us and will apply the things that we need to apply when we do it. So let me jump into a terminal. We're going to cd out of Terraform, and we'll go over into the Helm directory. And let's just make sure that this Helm chart is working before we get started. So we'll go Helm templates. You have to give it a name. We'll just call it foo. And the current directory is where it is. And so you'll see we're rendering out all of the manifests properly right now. So the chart works. So now what we want to start doing is adding JSON schema validation to the values.yaml. So let's take a look at the values.yaml here really quick. It's a fairly short list here. One thing that I do need to mention is that unlike Terraform, where you declare your variables and then can define them separately, in Helm, you kind of have to do both. And the reason for that is in Terraform, you can say there's a variable named foo and it's of type string. And Airlock can then look at that and say, okay, there's a variable type foo, this type, or named foo, this type string. If we don't give types here, for example, if we just left this blank, which sometimes happens in values files, they'll leave these things blank. There's no way for Airlock to be able to know what type replica count is. There's no way for it to know that it's an integer, right? And so every value that you want to be converted into JSON schema, you have to have a default value for it so that Airlock can infer what type it is, if that makes sense. And so, in fact, let me leave it like this. Let's run Airlock, and you'll see how it's going to print it all out. And then I'm going to remove the definition of one of these values, and you'll see Airlock is going to error as a result. So if I do Airlock Helm inputs values.yaml, so it's the same command, subcommand, it's just under Helm instead of Terraform, and you also pass it a file here instead of a directory. And so if we do values.yaml, you'll see it's going to render this out, and it is a bit bigger than the Terraform one was, right? However, if we do what I just had mentioned previously, if I remove the definition of replica count and save, you'll see Airlock can't determine what replica count is. Actually, I'm surprised it did that. It may have just skipped it. In fact, I think that's what we do is we just skip the values. Yeah, you'll see it's not in here anymore. The image, we just skipped over that value. We didn't render it because we can't tell. When I say we, I mean Airlock can't tell what type it is. So that's what's going to happen. If you want JSON schema on it, you have to make sure you specify a value. So now that we've covered that, let's go ahead and dump that JSON schema out to a file, and then let's start using that file to validate the inputs on the values. So let's do, let's jump back into the terminal. Let's do Airlock Helm input values.yaml. And now we're going to dump this to, it actually is a specific file name that is required by Helm if we want Helm to actually use the schema for validation. And that name is values.schema.json, just like that. And we're going to put it in the current directory. It needs to exist alongside the values file. So if we look now, there's values.yaml and there's values.schema.json. And so Helm will actually use this schema file when it's running install, upgrade, lint, or template. And as long as it's in this in a file named this specific way, values.schema.json. So let's run that Helm template command again and make sure we haven't broken anything. Okay, it's working. However, there's no real way for us to tell whether or not it actually used that schema to validate. So what we can do is let's jump into the schema, let's tweak it a little bit, and see if we can get it to start failing the values. So let's open it up in the terminal. So replica count. Let's say that the company policy is that every application, or at least this application, needs to be run highly available, which means that we have a minimum replica of 2. We have to run at least 2 replicas of this application. Let's now jump back over. If we actually look at the values is still set to 1. So technically, these values now are in violation of the JSON schema. So let's try to run Helm here, and you'll see this is Helm automatically. This isn't Airlock doing the validation. This is Helm using that schema to identify that the replica count must be greater than or equal to 2, and it's not. So let's jump back in. Let's update the replicas to 2, and let's see if that fixes it. There we go. And now Helm template is working once again. We've already kind of seen that example. Let's see it with a string. So let's say that we have a policy that Nginx must be, we have to use a recent version of Nginx for the tag. So if we look at the way this is set up, we do want to use Nginx, but we want this tag to be a certain version or higher. And so I believe right now we're on like 1.26. Let's just assume that the company policies, we need to run at least 1.20. All right, so what we can do is we can jump into values.schema. We can go down to the tag, and we can add a regex pattern here. So it goes under the key pattern. And now this is going to be a string that is a regex pattern that must be met. And so what we'll say is it needs to be 1 dot, and I think we said anything 1.20 or up. So it needs to be 20, 0 through 9, like this, and anything after. And so what this is now saying is the pattern needs to start with 1, have a dot, and then it needs to be either 2 through 9 and followed by another character. So this will work 1 through 120, all the way up through 199 and above, because this dot asterisk allows anything after it. And so this will allow us if we want to do like 126 Alpine or something like that. And so let's now run this. And this should now fail because if we look at the values.yaml, the tag is empty. This is going to be invalidation. It does not fit the regex. And let's see if Helm identifies that. Absolutely. It doesn't fit the pattern. So let's go back in and let's say, all right, the tag that we're going to use is 1.26.6, just like that. And if we run it, there we go. It's working again. And so this is really cool to see that Helm has actually already identified the value of JSON schema in performing input validation. And Airlock now can really help you convert your values file into JSON schema because it's, as you've seen, JSON schema is very verbose and it can be very tedious to write it all out. And so Airlock can get you to a very good starting place where you can just start adding in all of the constraints that fit your organization. So that's about as much as I want to show of just Airlock itself and JSON schema. Before we wrap up, I'd actually like to talk a little bit about why we at Massdriver even invested any time into this tool and why we're releasing it. All of these ideas around input validation and guardrails for your infrastructure as code are core to the concept of what we call bundles. Bundles are it's basically just IAC that can be configured, connected, and deployed in our platform, Massdriver. And so I actually like to show you how Airlock integrates into our CLI. Like we had to build Airlock to give some of the functionality to the CLI to enable bundle development. And we're now releasing that tool to the public. And so I want to show you how Airlock is going to enable it very easy bundle development experience. So you can turn your Terraform modules into bundles that can be deployed safely by anybody at your company. And so to demonstrate this, I'm actually going to create a bundle here on the fly based off of that simple Terraform module that we made earlier, just with the random pet and the random password. So in order to follow along with this part, you're actually going to need the Massdriver CLI, which you can download. If you go to our GitHub org, Massdriver-cloud, it's the Mass project, MASS. And I dropped a link at the start of the webinar if you go back in chat. So let's go up one directory. We're going to add the bundle directory here, and we're going to run mass bundle new. This is the process for creating a new bundle. We're just going to name it Airlock example, and description. We'll just say an example Airlock bundle like that. For the template, we're going to scroll all the way down to the Terraform module. We want to use since we're going to be building this off the Terraform module we had earlier, that's the one we want to use. And now this is actually where Airlock is starting to be integrated into the Massdriver CLI. This is asking where the Terraform module is, which if you remember when we were doing this with Airlock, it's going to scrape that Terraform module, extract out the variables, and automatically create the schema for it. So if you remember, it was just in, not from Terraform, it was just in the Terraform directory. And we don't need any connections. We'll talk very briefly about what connections are later. So we'll just say none. Output directory, you can call it Massdriver, or we can call it bundle, whatever you want to call it. It should get dropped. And so there we go. Now we have a new directory called bundle. If we open this up in a terminal, then we close all. No, we don't need to save that. We close all of these and we open up the bundle directory. You'll see there's this massdriver.yaml file. And you'll see that these params look exactly like what Airlock was outputting when it was running against the Terraform module. And so this is in Massdriver, the concept of bundles are like input parameters. And so we're rendering all of the inputs to your Terraform as JSON schema here in this Massdriver.yaml. So the only thing we have to do now is we need to copy over, we need to remove the existing Terraform that's here, that's just boilerplate, and we need to copy in the main.tf from the other file. So let me cd into bundle source, and I'm going to remove everything.tf, just like that. And now I'm going to copy, if I go up to Terraform, I'm going to copy in main.tf. There we go. That's all we need to do. Now, one thing I will note, or I will mention very briefly here, is that you'll notice I didn't copy over the variable declarations, the variables.tf. This is something that we're actually tweaking right now in the Massdriver CLI and bundle development process. Right now, we actually auto-generate all of the variables for the params. And you actually see that here. When I run mass bundle publish, you'll see that we're going to generate a bunch of the variable declarations. So if I would have copied over the variables.tf, it would have actually had duplicate declarations, which would have caused an issue. We're going to be tweaking the Massdriver CLI so that the generation of those is actually optional. And so you can bring your own variables.tf, or you can allow us to auto-generate them for you on the fly. And so we want to give that power to our users to be able to manage their Terraform however they'd like, whether they manage it themselves or they manage it with, or if they use Massdriver to actually auto-generate. So now that we've copied that in, let's just go up one directory and we'll run mass bundle publish. There we go. So this published this Terraform module, this bundle, to my Massdriver organization. So let's jump into Massdriver right here. Let me zoom in a little bit. Actually, let me make this bigger. There we go. That's a little bigger, a little easier for everybody. So now I need to refresh the page so that we get the Airlock in here. If I now search, you'll see that bundle I just made, Airlock example, is right here. So I can drag this now onto the canvas. We'll just name it Airlock. And what's really cool is now if we look at the config, we're able to render JSON schema as a rich UI. And so everything that was that we were previously having to just fill out is now is rendered here. We can change values just like this. We can add the length here. So let's just say the password length is going to be 8, the pet length is going to be 2, and we can even deploy from here. So I can say deploy. And now this is going to send it off to our provisioning system, and it's going to execute the Terraform. Now this isn't actually going to, it is going to run the Terraform, but again, it's just a trivial example. It's just going to make some random pets. But what I want to show now is how we're able to enforce JSON schema actually in our UI. So let's go back into, and you can see there, it's provisioned and it's running now. Let's say that down the road, we want to actually add more constraints around the bundle that we have. So let's just say for password length, let's say the minimum has to be 12, because remember that was our company policy. And let's also say the password special must be type true, like that. Same thing that we did earlier. Actually, instead of doing that, what I would like to show is enums. So that's actually, this is how you can make it a really rich UI experience. So we can say the pet length is a number. We can actually say it's an enum, and it must be either 2, 3, or 4. Let me save that. I think this will make for a better demonstration. So let me publish this again. If we go back into Massdriver, now let me try to configure this. If I try to just deploy this the way that it is, you'll see we're actually going to get, it's going to block us from deploying because the value must be greater than or equal to 12. And so now we're not even having to run Airlock or pass things through any JSON schema validation. We're able to be notified right here in the UI when we're violating the schema requirements. So we can update this to 12. And you'll also see the enum is now this very nice, easy to use drop-down menu. And so you can create these enums that can have very specific settings that perhaps are applicable. So instead of opening it up and letting anybody specify any value they want, you can say, nope, only these 3 values are going to be accepted, right? So let's go ahead and deploy that again. And it's going to send it off to our provisioning engine. So the last thing that I'd like to mention here before we wrap up is that our use, hopefully you see the value of JSON schema in the inputs, but in Massdriver, the JSON schema doesn't just stop at input parameters. If you look at the canvas here, you'll see that there's these lines that are going between these different bundles. So we have a VPC here with lines to Aurora Postgres and EKS. These lines are more than just a visual relationship. When you create a bundle, like we just did with this Airlock example, you can optionally create one or more what we call artifacts. Artifacts are going to be these little nodes on the right-hand side. These artifacts behind the scenes are really just structured JSON. It's structured JSON output, which describes the infrastructure that was within the bundle. And so this VPC, for example, can pass along information like the VPC ID or ARN, the different subnet types, public and private subnets, the ARNs of each of those subnets, the CIDR, whatever information would be relevant. Terraform has this concept kind of with outputs. However, this only works when you're going Terraform to Terraform, right? You can use the outputs of one Terraform module in another Terraform module. But if you want to go Terraform to Helm, or Helm to Terraform, or CloudFormation to Terraform, or Bicep, in Azure to Terraform, there's no cross IAC compatibility. So, but all of these things speak JSON. So by formatting these outputs around structured JSON, what we can do is allow interoperability between our IACs, between the different IAC languages. And so VPC can pass the structured JSON to the EKS cluster, to Postgres, and these could be written in whatever. They could be written in Terraform, and they can bring in that structured JSON as an input, or it could be written in CloudFormation, and we could bring that in as an input. And so what this allows is, and by the way, these artifacts are all defined with JSON schema. So you have a guarantee of what the structure of this JSON blob is going to look like. It's not just going to be arbitrary. It's going to be a very specific structure with requirements of certain values. So now you have a contract that these bundles will produce a very specific output that you can now build bundles that can take in that input regardless of the language and operate off of it. And so this becomes very, very powerful of the ability to write your IAC in whatever tool is best suited for it and still be able to communicate between all of the other IAC platforms. So this is why we're really excited about Airlock. So nothing else really to demo here. We'll just go ahead and wrap up the webinar. So what we went over today is Airlock, which is the open source project that's being released by Massdriver that allows you to translate back and forth between different IACs, specifically right now, Terraform and Helm, to JSON schema, and from JSON schema back into a Helm values.yaml or a Terraform variables declaration. This JSON schema provides rich input validation to make sure that the right values are there and that they don't go outside of the constraints that are fit to your business and your use case. What this really allows, and what we're really trying to get to, is developer self-service. We want to help operations engineers get out from ticket fatigue. We want you to be able to write your IAC once, publish it like we just did in Massdriver to our bundle catalog, and make it available to everybody in your organization. And they can now use it safely because you built in all of your expertise and safety into the bundle itself, into the Terraform, into the IAC. They don't have to worry about putting in the wrong inputs because you can put the proper validation around it. You can truly enable developer self-service and platform engineering for your organization by leveraging things like Airlock for input validation, and platforms like Massdriver for platform engineering. So with that, I will wrap it up. Please check us out if any of this is interesting to you. It's massdriver.cloud. If you have any questions, you can reach out to me, Chris at massdriver.cloud. And if you're interested in this at all, you can head to our webpage and you can schedule a demo there. You can sign up and give the platform a try. So I'm going to let this run for a little bit. If there's any questions, feel free to ask it in Slack, and I'll try to answer it. But otherwise, we'll shut this down in just a couple of minutes.